Okay, hi everyone. So what we're talking about now is limits. And we did simple limits like what would it look like at a simple graph point? No problem here. But I want to talk about what's going on the graph that you see right now. Before we answer the question, I want to talk about what is going on with this graph. We're going to talk about the directions we're headed and what does it look like. So right now, if people are around you, you can just whisper to yourself so you don't look crazy. But I want to ask you this question. What does it look like as x gets closer to infinity? Okay, what does it look like as x gets closer to negative infinity? What does x look like? So what does the graph look like as x gets closer to -4 from the right side? What about -4 from the left side? And these are the characteristics that we're trying to catch right now when it comes to limits. And it's important for us to be able to talk about this in this easy way of, hey, this is what's happening with the limit. Or I have no clue what's happening with the limit. Now the limit is always the y value for us. The limit is the y value, the result, right? The point on the graph, the answer. So if I talk about, let's say this is my money graph, okay? As x is getting closer to -4, see how the money shoots up to infinity? It is ever increasing, it's shooting up, okay? But as x gets closer to infinity, where am I stuck at? And this is where we talk about horizontal asymptotes and vertical asymptotes, because horizontal asymptotes get close to a number, but they never ever really touch it, okay? How about vertical asymptotes? Remember, they shoot off to infinity, right? This is going to shoot off to infinity, and we have a way of describing it now. Okay, we have a way of describing it now. So I'm going to write a couple things using this example here, and then we can then answer this question very easily. So first, we'll call this f of x. This is f of x, the graph of f of x, okay? And f of x is represented by this vertical asymptote and actually two separate horizontal asymptotes. I want you guys to first notice that the first horizontal asymptote is right here. It's not at 0, it's actually at 1. Let me go ahead and take my little graph here. And if you take a look here, it's actually at 1. The left one is at 0. So we can have horizontal asymptotes go in totally different directions, and that's perfectly fine. So, but we want a way to describe each and every one of these four aspects of this graph. So let's go ahead and get started. So limits say, what does it look like? So let's do the easy one. What's the limit as x approaches infinity? Okay, what is the limit of f of x as x approaches infinity? So what is this statement saying? I'm saying, what does the graph look like? What does f of x look like as x continues to beat on infinity, as continues to keep going to the right, continues, and continues to the right? Please look at positive infinity. We see positive infinity on the right side of the graph. Left side would be negative infinity. So can you guys type in the chat, what does the y value look like it's going to get stuck at as y goes to infinity? If you guys could type that in the chat real quick, please. I would much appreciate that. So you guys can see, I want to see if you guys are on board here. What does the y value look like it's going to become as x continues to the right? What do you think the y value is going to be? Is it going to get larger? Is it shooting up? Is it shooting down? Or is it getting stuck at a number? Thank you for the guys who are trying it. And if you look here, the graph is actually getting stuck at y is equal to 1. 0 is right here. And you can see the graph isn't dipping down. It's not coming back down, right? It's not all of a sudden coming down here. It's actually already stuck. The graph is stuck up here. And the graph looks like 1. And that's what limits are saying. Why do we even need this concept of a limit? Because there's no way to say in math, we can't say what is f of infinity. That makes no sense because because infinity is not a number. We can't just plug in infinity, but we can get the idea of what would it look like if I could get to infinity. And the answer is 1. It will look like 1. But we talked about horizontal asymptotes before. Can it actually ever be 1? Will it actually ever touch 1 in the end? No, it'll get super close to it, but it'll never actually touch 1. So thank you for participating, you guys. So that's the idea. What does it look like? It looks like on the right side as x gets closer to infinity. So this is the most important part right here. Where do you want me to head? I want you to head to infinity. Tell me what the y value is when you get there. You told me to go to infinity, right? Yeah. So what you do, you take the shortcut. What does it look like? It looks like 1, and then go home early. On the left side, let's try the next question following this. What is the y value? What's the limit as x approaches negative infinity? So as x is going in this direction, okay, in that direction, what does it look like the y value is stuck on? Do you think I got to -1? Do you think I got to -2 or -3? Do you think I got that low? Thank you very much. Let's see if anyone else has, if you guys agree or disagree with that. As x goes to negative infinity, we're looking at 0. Would you guys be okay that we are stuck at 0? Do you think you have enough energy to go to -1? Do you think you have enough energy to go to -2? Do you see how it's actually tapering off already, right? So this is actually not getting lower. It's actually would get stuck here. So what would it look like? It would look like 0. Thank you. Great job. And that's our point, is like, I don't need to get to infinity, right? I don't need to get to become a millionaire to see what the world really looks like. I just have to have a nice savings. The idea here is that I can tell you what it looks like without actually getting there. Now, here's our next other options. If you look at 4, remember 4 doesn't exist, does it? F of 4 does not exist. But I want us to be able to talk about it, right? And the question is, what's the limit as x approaches 4 from the left side? And what is the limit as x approaches 4 from the right side? And if you notice, these almost look exactly the same, except for this plus and minus sign. And the plus and minus sign here refer to one-sided limits. One-sided limits. So from the left side or the right side? So let's look at this one. This is my left side. From the left side, as I approach 4, what happens to the y value? Does it just blow right on through? So as we get closer to 4, the y value is kicking me up. It's forcing me up. I'm caught in the riptide. I'm going to get lost in the ocean. But do you guys see it's pushing me up? Where do you think that value is headed toward? Nirvana? Valhalla? Right? Are you guys okay? It looks like it's headed toward infinity. Okay? So if I head up, I'm headed toward infinity. So I can use the idea of infinity. We've never used infinity really for an answer before, except when we talked about end behavior. It's going off, shooting off to infinity. But this is our mathematical way of saying, what does it look like? I get it, 4 does not exist. But if you could approach from the left side, where is it headed toward? What would it look like? What should it look like? Not what is it? Because it is nothing. It does not exist. How about the right side? As I approach from the right side of the graph, I'm stuck on this roller coaster. You can see on the right side, I'm heading toward infinity. I'm heading toward 4 from the right side. And this is the idea. I'm heading toward this number, okay? Now let's go ahead and look at this. Choose the correct statement. Which of these is true? Is it true that, read this please, the limit as x approaches 4 from the negative side? Let's go and take a look here. What do we have on the negative side? They're telling me as I approach 4 from the negative side, okay, I'm approaching 4 from the negative side, it's going to be negative infinity. Does that look like it's heading down toward you for you? No, it's heading up to positive infinity. That's our answer. So this concept of what is a limit, how do we solve it, how do we use it, super important, 100% important, right? Because it allows us to make statements like, what does it look like? Not what is it? The answer is nothing, it's nothing. There's nothing at -4, but it sure does look like infinity from the right side. I have a similar statement here. Does the graph look like it's going to positive infinity, negative infinity? Okay, it looks like it's positive infinity, right? Do you guys see from the right side is shooting up? Let's go and verify that. I'm heading to +2, sorry, -2. That's always a trick question. Careful about the signs. I'm heading to -2, here's -2. But from the left side, see how that's left? And it's shooting up, right? What's the y value? It's gonna be infinity, positive infinity. Thank you, perfect, positive infinity, good to go. That's right. So this is how fast these can be. And for some kids, when they enter calculus and they don't understand what a limit is, they can't read it. And you're like, what? It's just what should it be? It's nothing more complicated than that. Sure, when we start solving it algebraically, it gets more complicated and we have rules for it. But the rules are really from pre-calculus, and we've actually learned all the rules already. So the graph of following f of x, the dashed line is a vertical asymptote, thank you. Now, which of these is true? If I approach from the left side or right, oh, these are both left side. So let's go ahead and look at this. Now, all these small little notations are important for us. And if you're a master in any field, these little notations mean something. Even Brian, I bet, when you're at Jamba Juice making drinks, there are some key things there that if you didn't work there, you wouldn't understand what that meant. So every job, everything has its own little nuances. So I'm looking at -1 from the negative sign, meaning from the left side. So from the left side, as I approach -1, here's -1. What happens to the y value? Am I shooting up or am I shooting down? You can see I'm going to hell, right? Sorry, I'm going to negative infinity. Okay, and that's really what it is. It's just us being able to identify where we're headed. Okay, let's take a look at this one. Asking us, again, we are heading to -4 from the left side. So here's the left side, right? -4 from the left side. Does it look like it's going to go up or down? Measurements, yeah. Shorthand. You guys might have learned this in geometry or algebra where they say like 9 this, like 7 these, and 9 these. What do those little lines mean? And if you ever see this in measuring, it's 7 feet, 9 inches. Okay. But yeah, measuring. You guys remember this little symbol here in algebra, or it's geometry? Perpendicular. These little symbols mean something. It allows us not to write the word perpendicular. Perpendicular. So much writing. And that's what we write here. But the limit is a way for us to not have to write this huge paragraph trying to explain to me what we're trying to do here. But a common understanding of limits is what should it look like? What does it look like as I'm approaching -4 from the negative sign from the left side? So instead of me having to write, imagine if I have to write left, whoops, left every single time, right? More writing. And we've learned a lot of brief notations, for instance, with logs, with square roots, exponents, all these are shorthand. Okay, so we said we're heading toward positive infinity. To infinity and beyond. Okay, let's jump to something harder. Now this graph has a lot of things going for it. Now let's read the question. We are headed to where? We are headed to 3. Now what does that little plus sign mean on the right, on the top corner? That's from the right side. So that's fine. 3. Here's 3. We have 3 and 9 to worry about. But we are going to 3. We are going to 3. We're not running away from it. We're running to 3 from the right side. Okay, see that from the right side? And the y value looks like it's going to take off to infinity. Infinity. Let's reiterate that one more time. So the limit as x approaches 3. Yes, we are headed toward 3, going there right now. From the plus means right side, from the right side. I'm going from the right side because I see a plus sign. What's the y value? As x gets closer, the y value is shooting up and climbing up and up and up. So if you guys can get that with all these practice problems, you guys are going to be in great shape. This looks like a lot of stuff going on here. Okay, a lot of stuff. But we don't care about that. We care about what's the question. The question is asking specifically, what's the limit? What does it look like as x approaches 4? Here's 4, right? 4 from the right or left side. It's important because a lot of stuff is going on at 4. So here's my line of 4. We're approaching from this way. What happens to the y value? Take the roller coaster to hell. See, on the left side, it's heading toward to negative infinity. It's hanging down. How far does it go? It goes toward negative infinity. Negative infinity. And if you have to, you take your pencil and just follow that line. Where does it go? I know. Thank you. Good work. Okay. And that's your practice day. That's our first one. So it should be pretty fast. I'll make sure you guys are totally good with that. Let's go and look at the second one, G2. Now this end behavior, we are looking at the graph, okay? Tomorrow, when I see you guys again, we're gonna look at end behavior without the graph, just the equation, okay? Without the graph, just the equation. And we're still gonna be able to do it just as fast with the same amount of accuracy. We don't have to draw it. Drawing helps us understand what's going on, and then we can do it without the graph, okay? Here you go. Using a graph of f of x to find the limit, the dashed lines are asymptotes. Thank you. We have asymptote and asymptote. So asymptote. Yeah, that's my asymptote, right? So let's read the question and see if if we're able better to decipher these limits now. The limit as x approaches what? Approaches positive infinity. So what does the graph look like as we approach positive infinity? Where's positive infinity? Isn't positive infinity to the right over here? So what is the y value stuck at? What does it look like it will be? Hopefully you guys can see the numbers is 4, 5, 6. It's going to be 5. Now, follow up. Will this ever really be 5? Look at that line. It looks like it's so close to 5. It's so going to be there. But the answer is no. It's our horizontal asymptote here. And it's going to eventually look like 5, like really close to 5. 4.9999999999999999999. And it won't ever really be 5, but that's not what limits say. Limits say, what would it have been? What should it be? What does it look like it's going to be? If Mr. Ko puts some money in some doggy coin, what does it look like it's going to be? To the moon, right? To $1, doggy coin for $1. Even now, if you go into doggy coin and it goes to $1, you've only doubled your money. But man, okay, so what does it look like? We all have dreams. We said it's going to be 5. Okay, same idea here, very similar question. Similar question. Okay, this one looks a lot of stuff is going on here. A lot of limits that we could talk about. But let's just answer the limit that they give us. What does the limit look like as we approach negative infinity? Okay, so we're looking at negative infinity. Where's negative infinity? Negative infinity is going this way. And what's the y value? Remember, we have to hop on the graph, and the graph looks like it's going to become, that looks like 6 to me. That's what the graph looks like. So the idea of here limits is just from what does it look like from a graphical point of view. In our last homework, we looked at it and said, hey, what does it look like if it does exist, does not exist, from the left and right side? And now we're looking at end behavior and as we go off to infinity. Limits allow us to say infinity. It looks like it'll be infinity. Okay, so we said this was going to look like 6. Okay, so a lot of stuff is going on. And that's your problem set today. That's it. So get this done right now. You guys have a couple more minutes of class, and you could probably finish this within this period. We'll talk about how to do this algebraically next time when I see you guys tomorrow.